the length of a rectangle is 3 more than twice the width. Determine the dimensions that will give a total area of 27 meters squared. So these are lovely math teacher-made situations that would probably not ever happen in real life, but do help you learn how to do this problem. Don't worry, I've got one that's a little more realistic for the next one. So we know the length of a rectangle is 3 more than twice the width. So if we have our rectangle, we've got the length and the width. So I know to find area of a rectangle, it is very simple. Area equals length times width. Right? And I know that my area is 27 meters squared. So I know I'm going to have 27 equals length times width. But there's no way for me to solve this equation whenever I have an L and a W, because I've got two variables there, so I can't know what the dimensions are. So what I have to do is I have to use this information that was given to me here. The length of the rectangle is 3 more than twice the width. And I know it sounds like super confusing at first whenever you hear it. But what you want to do is go through and just think of what each word tells you to do when you're writing an equation. So length tells you to write an L of a rectangle. Is, what does is tell you to do as far as math goes? To put as far as math symbols go. Equal sign. So L equals 3 more than. So 3 tells me to write 3. What does more than tell me to do? Plus twice the width. What's that tell me to put? 2 times the width. Or you might have L equals 2W plus 3, because you could switch the order on that. So, and actually, I think it's going to be maybe a little easier to deal with if I make it 2W plus 3. I think it just looks a little prettier. So the length is the same as 2W plus 3. So if the length is the same as 2W plus 3, I can replace L with 2W plus 3. So that means in this equation right here, I can take 2W plus 3 and I can put it right there for the L. So I get 27 equals 2W plus 3. Make sure you put it in parentheses whenever you put it there, and times W. Now that did make my equation look a lot more complicated, but everything is in terms of W now. So I can solve this because it only has W's in the equation. So if I want to solve this, what I'm going to have to do, it looks a little bit backwards, but these two things are multiplied. So I could think of it like this: 27 equals W times 2W plus 3. If I write it that way, it becomes a little more obvious what you should do. What would we do with that W? We'll distribute it. So I get 27 equals 2W squared plus 3W. And I didn't give myself enough room there. Okay, so once I do this, I have a quadratic. How do I solve a quadratic? We've done a lot of quadratic solving. Before I do anything, unless you're going to complete the square, which I would not suggest on this, because 2, you'd have to divide everything by 2 first, and then you get a 3/2 for your b. So I would not say complete the square. Is very, very easy here. So the first thing you want to do with a quadratic, what would we do, Trace? Move the 27 over. You want everything on one side. So we got 0 equals 2W squared plus 3W minus 27. So move everything to one side. Okay, so for this case, we've got this equation, and we want to know what W is. So you've got, I don't think it will factor. Maybe. We'll see if we get a hold. Let's see if I got this written down somewhere. I think I do. No, it will not factor. So since it will not factor, and completing the square would be painful for this one because you would end up with a 3/2 that you gotta divide by 2 and square, and I just don't suggest completing the square on this one. Let's just use quadratic formula. So x equals opposite of b plus or minus square root b squared minus 4ac, thank you, all over 2a. So we get negative 3 plus or minus the square root of 3 squared minus 4 times 2 times negative 27. Oh, 225. It would have factored, actually, because the square root of 225 is 15, so we get negative 3 plus or minus 15 all over 4. Really, I should have called this a W here. Notice one thing here. This was a big mistake I saw on that last test that we took. When you take the square root of 25, it is 15. It is not the square root of 15. Do not leave a square root with that 15. Okay? So make sure you don't have that there. Because you have taken the square root of it. It is no longer underneath the square root. So to get our two answers, we'll first have to do negative 3 plus 15 divided by 4. And that will give us 3, so we get W equals 3. And then we'll have to do negative 3 minus 15 divided by 4. And that gives us negative 4.5. Okay, now let's talk about something for a second. Can the length of your rectangle, the width of your rectangle, be negative 4.5? You cannot have a negative width. So on a lot of these types of problems, when we get one of these answers is negative, we're going to throw it out. It isn't a solution to that equation, but it doesn't make any sense in real life, so we've got to throw it out. So 3 is the only width that really works. It asks for dimensions. So for dimensions, dimensions means length and width. How do I find the length? What? Okay, how do you know it's 9? Yes. So we're just plugging it into that equation, right? So we're plugging it into that equation. 2W plus 3. So 2 times 3 plus 3. So 2 times 3 is 6 plus another 3 will give you 9. So your dimensions are 3 times 9. Is there another, or, well, let's see, let me write it like this. 3, and I should put units here. Meters. So 3 meters by 9 meters. Is there another way you could have figured it out besides plugging it in? What's the area? 27. And length times width has to give you the area, right? So if one of them's 3, the other has to be 9 to get 27. So you could do it that way also. Okay. Alright, so if you ever want to make a rectangle with this particular condition, you know what length of your side you need to make. Okay. Questions so far? And hold on just a second. I need to rework these notes. I did not remember them being quite so bad from last year. I need to rework all this. So let's pause this. Okay, so whenever some of you guys graduate from high school and move out west to become a rancher, you may find yourself in this particular situation where you have 100 yards of fencing and you want to make 2 rectangular corrals like so, and you need to know what will give you the maximum area. You could just guess at it and figure out, like, let's think of just some of the dimensions we could use, because figuring that out is even a little bit tricky. It doesn't. They have to be rectangles, but they don't necessarily have to. Does not necessarily have to be a square. So now we do know all 3 of these lengths would be the same. And I will say this. It doesn't say it for the problem, but we do want both corrals to be the same size. But it doesn't mean that this has to make a square. But it does mean, like, if this right here is X, then I want this right here to be X. Alright. And then, like, we'll call these Y and Y and Y. So, like, let's just play with it a little bit. Okay? Like, if we're just, let's say we're the rancher and we just want to, like, guess and check. Like, I could make them, like, 10 and 10 here. So it'd take me 10 yards here and 10 yards here. Alright? And so if I did that, how much fencing would I have left to make these 3 lengths? I would have 60. So what should they be if I've got 3 of them? 20 each. Okay? So I could do that. That add up to 100. Or, let's see if it'll let me copy and paste this. Ooh, that is not what I meant to do. Well, it's not letting me copy and paste that. Let's try something else. Let's say that I let each one of these lengths be 10. Okay, so if they're all 10, what does that leave me left over with to do the ends with? 70. So what would I have to do to find each one of these little pieces? 70 divided by 4. Somebody do that for me. What do you get? 17.5. So we have 17.5, 17.5, 17.5, 17.5. So if I do this, like, let's just compare the two that we've thought of so far. So, like, right here, the area of this is 20 by 10. So this has an area of 200, and this has an area of 200, so 400 total, right? Here, I've got 17.5 times 10 is 175 and 175. So the instance with the 10 and 20, that would be better than this one over here. But there's like an infinite number of ways we could think about this, right? We could go back and do this, and we could make each little piece, each one of these vertical pieces 15 and figure out what we need for our x's. Or we could make each of these little x pieces 2 and figure out what we need for our y's. So we've got to figure out what would be our maximum area. Okay? So we can use math to help us figure this out so that we have our animals, whatever animal we're keeping in our corrals. What are we going to keep in there? Kangaroos. So whenever we are corralling our kangaroos here, our domesticated kangaroos that we are raising, yeah, they're going to have to be real tall. Yeah, so I like kangaroos. They're really cute. Alright, so let's do what I had before. Okay, so basically what you're going to have to do for these problems is you're going to have 2 equations you've got to come up with. Okay? You're going to have one equation that you're maximizing or minimizing, and you're going to have another equation you use to solve the problem. Okay? So in this case, what are we looking for to be maximum or minimum? Is it area? Is it perimeter? Is it volume? What is it? We want area to be maximum, right? So it tells us right there, area is maximum. So that's the one we want to type into our calculator and find the maximum point of. But here's our problem. The area of this equation. So if I have it labeled like I labeled it here, my area would be, I could just do like the area of the whole thing, right? So this side is y. What's the length of this side? Not x squared, because that would be x times x. We do 2x, because that would be x plus x. So my area is 2x times y. So I'm going to type 2x times y into the calculator and find a maximum. But is that going to work right now with an x and a y? It is not, because I can't put a y into that calculator and it do anything for me. So what I have to do is use my other information so that I can replace that y with something. Or the x, it doesn't matter, but I like to replace the y most of the time. So my other information is right here. We know we have 100 yards of fencing. That's our limiting factor here, right? So I know 100 has to equal what? When I was trying to get this to work, I had like 10, 10, 10, 10, and then 20, 20, 20. I knew that would work because all of those added up to be 100, right? So that 100 is sort of like perimeter, but in this case it's not just perimeter because you also have this line right here through the middle. So I've got x, 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 x plus y, 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 right? So 100 equals 4x plus 3y. So if I solve this equation for x or y, it really doesn't matter which one you choose to solve for, then I can put that into my a equation and it will be all in one variable. Okay, so what I'm going to do, let's see, Aaliyah, do you want to solve for the x or y? Okay, so if we solve for the x right here, then that means in this equation I'm trying to get that x right there by itself. I'm only solving for the x because Aaliyah told me to. I could do the y just as easily. So I'm going to subtract 3y. So I get 100 minus 3y equals 4x. And then I'm going to divide by 4 because I want that x to be by itself. Since I'm letting you use your calculator on this stuff, let's just leave it like that. So x equals 100 minus 3y over 4. Well, let me let you decide. Would you rather leave it like this, or we could do this? We could do the love connection. Have I taught you guys about the love connection yet? I've got to teach you about the love connection. Yeah. So, love connection tells you that I will try not to go into such detail about the love connection as maybe Coach Wood did. But the love connection here, when it comes to math, if you have a number on the bottom of a fraction, just a single number or a single term, then that means you can divide both of these terms by that number. So I could leave it like it is, or I could say x equals 100 divided by 4 is 25, and 3 divided by 4 is 0.75, or you could leave it 3/4. It's going to be easier to type in the calculator if we leave it like this, but you can do it either way. Okay, so we just divided both of those numbers there by 4. Okay? Alright, and it's, of course, called the love connection because you have this really cute little heart that's drawn there. The love connection may never be done upside down. Don't try it. You may hurt yourself. It is always has to be like this. If the heart's upside down, you can't do it that way. So if I had like 4 divided by 10 minus x, you cannot do that. That would be wrong. Heart cannot be upside down. Okay. So we have got x equals this stuff right here. So we can take that stuff and replace the x in our equation over here. So a will equal 2 times 25 minus 0.75y times y. Now, if I am going to write it like this. Would it be all right if I just take Mr. Y right here and put him over here with the 2 just so it looks prettier? I'm going to do that. So 2y times 25 minus 0.75y. Now, I can distribute if I want to here, but you don't have to if you're using the calculator. So everybody grab your calculator. Y equals, clear out anything that's already there. Okay, make sure any of your plots have been turned off. Right up here on Y equals, you can actually see your plots and see if they're on. If they're dark, that means that plot's on, so you want to turn those off if they're on. And you're just going to talk. Now, it won't let you type in 2y, so I'm going to have to use 2x. Instead of the y, because it won't graph it if you put a y there. Just remember when you get your answer, it's not the x value, it's the y. Okay. All right, we okay so far? Okay, we're going to hit graph. I can see part of my graph depending on what your window is. If you're back to Zoom 6, yeah, if you're at Zoom 6, you can't really see anything. Like if you're in that standard 10 by 10 window, you can't really see anything. So, what's it say beside the error? Syntax. Make sure you didn't use a negative instead of a minus in between your 25 and your 0.75. That's usually it, if it's that one. See if that fixes it. Or sometimes your plot might be on. Alright, so let's go to the table. That'll help us find some values maybe. So I'm looking for maximum area. The area is what is in for the y, right? So if I look, this is my area over here. I'm looking for it to go up and then back down at some point, and right there it was. Right there at 416. 416 looks like it might be the maximum. But don't trust your table necessarily because, well, I can sort of tell by the symmetry here it probably is 416. But don't trust your table because even though that might be the highest number on your table, sometimes it's not actually your maximum number. It's usually pretty close. Oh, yeah. Oh, there is a 4.16.5. Never mind. So even that, the 416.5, it still may not be my highest because it may have went a little bit higher than that and then back down. So what I want to do, this just gives me an idea of what I want my window to look like. I know that my y value has to go up to at least 416. So I'm going to probably pick like 450 for my y max. So I'm going to go to window and I'm going to make this y max 450. And so that I can see a lot more of the graph, but my x needs to change also. So if I make my x max, what do you guys think? Like 20? Okay, that'll work. And since I'm only finding maximum, all I really need to see is maximum here. It's okay that you don't see the whole graph here. So as long as you can see the maximum, that's going to work. So now we're looking for maximum. So we are going to do second trace. Which one do I pick? Number 4, maximum. And it's going to say left bound, so I'm going to go somewhere to the left side of the hill, which I'm going to get up here a little bit closer so that right here it's left bound. I'm going to hit enter, then it will say right bound. So I'll go over the hill and hit enter. And then it's going to work even if you don't tell it yes, but yes. And I get 16.6 repeating and 416.6 repeating. Now, I have to, what kids mess up on the most with these problems, well, sometimes it is hard to get the equation set up. So, but let's say they get the equation set up. What they mess up the most on for this after that is understanding what those numbers right there mean. So, the x and the y coordinates. What was our x for this problem? It is the y, right? Because that's what we had to use a y to type in for our calculator. So right here is our y in our picture. What is the y coordinates? Right, when we typed in this equation, we had to use an x in our calculator for this. What was the a right here? That was your y1, right? So that y coordinate, this is the area. So the maximum area you can get is 416.6 repeating, but the question says what dimensions should be used to make the corrals. So I know that y should be 16.6, so 16.6 repeating, 16.6 repeating, and 16.6 repeating. What should I use for the x's if that's the case? I could figure it out, right? I've got 16.6 repeating times 3. We've got 3 of those, so it's going to be 50. I just didn't put enough 6's there, right? So you get 50 for the y's, and then so that leaves you've got 100 feet of fence, you got 50 feet left, so 50 divided by those 4 x's that you got there is going to give you 12.5. So your x's will be 12.5 yards, and your y's would be 16.6 repeating yards. The other way to find that, let's say that you're not really following that, you can use that equation you had, 100 equals 4x plus 3y. We just found that the y was 16.6 repeating. So if you multiply 3 times 16.6 repeating and you use lots of 6's, you're going to get 50 for that. You would subtract the 50 from both sides. So 50 equals 4x, and then you'll divide by 4. So you get 12.5 for your x. Questions? So, whenever Brandon is trying to corral his kangaroos, if he had just guessed, like I did up here for this first couple, then his kangaroos would have been not enjoying the maximum possible area. They would lack about 16.6 square yards of area there that they could have had that probably would have made them upset. Made them angry. angry at Brandon, and they might have attacked him if they had found out that he could have optimized corral area there. So, of course, Brandon, whenever he decides to cage his kangaroos, might just decide to guess at this based on what he's got. But you could imagine if you were designing something much larger, which would make a much more complicated equation, but if you had a dairy farm that milked 200 cows a day, and you were worried about corrals, and you had like a certain setup you wanted, then that could, be something that maybe you would be considering. Okay, questions? Okay, let's look at example 5. Why do I have different examples here? Okay, so this is a question that they love to give you on AP, or not AP, this is not AP, but on final exam sort of stuff. I think they are good questions to consider. I think they are unfair when you put them on a standardized test because there's so many places you can go wrong that it makes it difficult to do these problems. So the heights of two different projectiles after they are launched are modeled by f of x and g of x. The function f of x is defined by this equation. The table contains the values for a quadratic function g. What is the approximate difference in the maximum heights achieved by the two projectiles? So we've got one projectile that for some reason we know the equation for. We have another one that we don't know the equation for, but we know some of the values for. Okay? So we want to know the difference between their maximum height. So let's work on these separately. Okay? So we'll call so f of x, let's work on it first. Okay? So for f of x, if I want to know the maximum of f of x, I could use the calculator. But I think that I actually prefer not to use the calculator on this one. Because I can find the maximum of this by finding the vertex. And to do the vertex, I could do negative b over 2a, which for this problem is negative 42 over 2 times negative 16. Okay? And we are going to use our calculator, but we're not graphing it. So negative 42 divided by negative 32 is going to give us 1.3125. Now that is the x-coordinate, that's the time. We want to know the y-coordinate because that's the height here. So what do I do with that to find the y-coordinate? I'm going to plug it in. So to plug that in, I'm going to have negative 16. Oh, let me show you this. Miss Hendrick always likes to do this, and it is helpful. Let's do this. Click. Like right here, you should still have this line right here. Have I showed you guys how to store a value in your calculator? Like store it as an A or a B or a C? Okay? Alright, so that one point, everybody try this. So if you did not do negative 42 divided by negative 32 in your calculator and get 1.3125, do that right now. Because I want everybody to try this. It is a pretty neat trick that will make it a little bit easier to plug numbers in. Especially if you're plugging in a negative number, it keeps you from making some mistakes there. So, alright, so right above your own key, you should see a button that says STO and has a little arrow beside it. So I'm going to click that button. So STO. This is especially helpful when you have really long decimals that just keep on going forever. But even for this one, typing in 1.3125 several times is kind of a pain. So I'm going to store this as X. So you just click STO with a little arrow. It's going to have this pop up and then just type in X. And so now the calculator thinks that x, like if you type x, it's going to tell you x is 1.3125. It has it stored as x. So if I type in negative 16x squared plus 42x plus 12, it's plugging in 1.3125 for me. So when I plug it in, f of 1.3125, it's going to give you 39.5625. Okay. Now you don't have to do that. You can type this in, negative 16 times 1.3125 squared plus 42 times 1.3125 plus 12, and you get the same number. So you don't have to do that. It's just a little shortcut, and especially if you have a really long decimal, it can make it a little bit quicker to put that in. And when you have a negative number, it takes care of those parentheses you need for negative numbers, so it can be helpful there too, so you don't mess that up. So not required, but optional. Okay, so our maximum height for f of x is 39.5625 feet. We did not have to do it this way. I could have graphed it and found the maximum. Okay, so I'm just trying to show you where we can use lots of the different things we've learned in a lot of different ways. Now, for the second one, I don't have an equation, so I've got to get an equation first. So, what are we going to have to do to get an equation for g of x? I heard it, the R word, regression, right? Sorry, my phone is ringing. Let me go ahead and type that into L1. All right, so let's go to stat, edit. Let's clear out anything that is there, which okay, so we're just going to type that data in, nice and short. Don't have to do a whole lot there. Okay, then to get the regression, we're going to do stat, over to calc, number 5. Now, before we hit enter, we really want to store this in y equals, because that's how we're going to find the maximum. So we're going to do bars, over to y bars, enter, enter, enter. And it actually gave us a really nice equation here. Our g of x, I'm going to write it down, is negative 16x squared plus 40x plus 9. And you can see that r squared value is 1, so it means that it fit perfectly. If you don't have an r squared, it's probably because your calculator has been reset. You need to turn your diagnostics on. So if you do second 0, that gets you to catalog. And if you go all the way down to the D's, where it says diagnostics on, and hit enter, and it'll say done, then if you do the regression again, it should show up. You don't necessarily have to have it to do the problem, but it is helpful, because I will tell you this, I am not going to put a regression on a quiz that has an R value of definitely not less than like 0.8. If you're getting R value, if your R squared value ends up being like 0.3, then what that probably means is you put one of your points in wrong. So now it's not fitting. So you don't necessarily have to have this R squared value showing up to do the problem. But if you see that it's really low, that should be telling you that something's probably wrong, because I'm not going to give you a data set on the quiz or test that fits really, really bad to answer the question from. So if you see that, that can be like an alarm that you may have done something wrong. But this one fit perfectly. So we could, if we wanted to, do exactly what we just did for the last problem. for this, because we could do negative b over 2a for this because we don't even have bad decimals or anything to deal with. But since we've already got it in our calculator, let's try to graph it. And I can see my graph, but it's a little tiny baby graph. So let's go and change. Let's go back to like a 10 by 10. And instead of 450, I think probably like 50 will do. Probably could have made it even a little less than 50, but that's fine. As long as you can see, we actually could have found the maximum from the teeny tiny baby graph, but you just got to be careful if you do that. As long as you can see the maximum, you can find the maximum. So then, Brandon, what do I click on to get to where I find the maximum? Okay, second Grissom. So second trace. And then which one am I going to pick? Number 4. Okay. It's going to say left bound, so I'm going to make sure I'm somewhere on the left side of the hill. I'll hit enter. It's going to say right bound. I'm going to hit enter. And I'm going to go back to the middle. Hit enter. So we get 1.25, 34 for this. So the y is my height. So I have 34. So I would do 39.5625 minus the 34. And let's see, 39.5625. I should not be doing this in the calculator. Why am I doing that? 5.5625. Yeah, so when it's that, this is what causes people to be bad with mental math, is because when the calculator's there, you just start typing in things that you should have the sense to know. When I was in college, I was a tutor in the math center, and I would have like students come to get help in their classes, and sometimes I would sit there and watch like college students, not even freshmen, usually like, juniors and seniors in college, type things like -3 times 0 into their calculator. And I would think to myself, how did you make it to college? How did you even get here? Yeah. But I think sometimes because it's there, you just rely on it, and just it is good. It's good on tests. I understand the sort of paranoia you get that maybe 2 + 2 is not 4 anymore. But when you're doing your homework, try your best not to type things into calculators until you have to. I mean, of course, I don't want you to plug 1.3215 into the equation without a calculator. But try to do that easy stuff in your head, and it'll make you better. That.